All right, welcome everybody. This is the third talk of this session, second to last. We'll have one after this. Raja was one of the original authors of the IROD software, and SRB before that, and so he's with us today to talk about policy-encapsulated objects. Go, Raja.
Okay, thank you. I'm going to talk about policy-encapsulated objects, like Terrell said, and I'd like to get feedback from all of you to see what do you think of it and if it is going to be useful in your own applications. My talk is based on some motivation to why we need PEOs, and also talk about what is a PEO, what is the makeup of that, and some architectural issues and maybe suggestions, and then finally get into Q&A. I should acknowledge Professor Regan Moore. I think Regan Moore should be somewhere up there. And we had some discussions on the PEOs around 4 or 5 years back, but we never got around to doing anything about them. Regan is part of the intellectual genealogy of the PEOs. In a sense, he retired around 4 or 5 years back and then went into hardcore genealogy. And actually, if you're really interested in genealogy, you can go and look this up on good old Google, CoreGen3, and Regan has written a software which is available on Google and also on iOS platforms, so that you can go and look up your genealogy. It's got a really large one. I would suggest you to do that. And like I said, we talked about it 4 or 5 years back, but we never got around to doing this. That is because once Regan left, the main workaholic of the group is gone. So we were left with only the slackers and things like that. So you can see why it took 4 to 5 years to get up to speed on this particular one. So let us look at from the IRODS viewpoint what IRODS does, and then from there go to PEO. So what does IRODS bring to the table? If you look at it, it is a federated virtual data space. Obviously, it also federates multiple other spaces such as user spaces, resource spaces, and on and on. And it has got a rich integrated metadata system along with it, and also provides very minute, rich system level information, very broad ACLs, audit trails, and so on and so forth. And it also provides you with a way of doing your distributed pipelines across multiple IROD servers and user tunable workflows and microservices, so that you can write your own pipelines either in the ingestion level or at the accession level, or anywhere you would like to do or for maintenance and so on and so forth. And it obviously has a very rich internal organ called the rule engine, which basically provides you with the multiple ways of doing things. And with the new IRODs, you can put your PEPs anywhere you want, wherever you want, and deal with it. So it is highly customizable right now. And using something like that, you're able to do multiple things, which are basically the bread and butter of IRODs. For example, you can do compliance, you can do provenance checking, you can do indexing, you can do integrity checking, you can do data virtualization, you can do secure collaboration, and on and on and on. Right? So IRODs as a space provides you with multiple types of things, not just a universal namespace and a federated data system. It provides you with a lot more capability than that. It's not just a distributed managed storage system, but far more than that. So in a sense, you can look at it as though it is providing you with what is called an extensible big data lifecycle management system. Big data, because it can go, we are not even talking about petabytes. Petabytes are passé now. So we can go about exabyte and etabyte and ottabyte and so on and so forth. I don't even know the names of some of those bytes which they are talking about nowadays. You can actually deal with that with multiple servers, multiple zones, integrated together, federated together, and talking to each other, and so on and so forth. And you can do what is called the fair data principles, which are becoming very common. And I was really happy to note that being mentioned earlier today also in the first part of the first session. about findability, accessibility, interoperability, and reusability. And this is basically the bread and butter of iRODS. It provides you with multiple replicas so that even if some replicas vanish, other replicas are there, and you can actually have a policy saying that at least keep 2 copies of it, and so on and so forth. Provides multiple ways of accessibility, and like we saw, S3 was one of them, GPFS was another one, and so on and so forth. You got a whole bunch of different types of things. And interoperability is basically you can have multiple copies of your data in different forms, either as a multi-valued things in your data sets, or as something which just changed on demand when the data is exiting the iRODS system. So you might be able to do that. And obviously, it provides with a lot of reusability. And if you ask Nirav Merchant, and he will be able to say why reusability is really important and how iRODS enables reusability. So we have a lot of these capabilities, and a lot of people are enjoying it and realizing it. But what is missing? One of the main things which is missing is the portability of the data set beyond iRODS. We are losing what I call as chain of custody. Chain of custody is basically something you need to make sure you are able to trust the data, so that you're able to say this data is what it was 2 years back, or what was created when it was created, and so on and so forth. So when you take a data set out of iRODS internally, you might be able to provide the chain of custody using access control lists and using good level of authentication and authorization, and also using audit trail. But once it is out of it, you don't have any control over that particular one. And even when you're doing these type of things, you lose all the things which we talked about before. Integrity maintenance, authorization, authentication, auditing, versioning, and so on and so forth are all lost as we get from take a data set out of the iRODS system. In a sense, we are losing the fair data principles. So things are good as long as they are inside the iRODS system, but even when you move it out, even move it out from one zone to another zone, you lose control. You lose who owned the data before, what version was it, and if there are any metadata, unless it is copied over, it doesn't go over. So you have what is called a dangling data life cycle, which is not really good for if you're really having some data which is really important and is useful for a long period of time and is going to be reused in a particular way. You might say that this is true not just for iRODS. It is true for any file system nowadays. If you put something in S3, if you put something in your own laptop, or you put something in a GPFS and things like that, once you take it out, they don't keep track of things. And it is a bane of not just of iRODS, but a lot of other systems where the chain of custody is completely lost. If I put a USB drive onto my laptop and take a PowerPoint slide and then give it to somebody else, and they download it onto their laptops, they become the owner, and all the information about it is almost lost. In a sense, the creation date is gone, and if I had multiple versions of that particular one, that chain of creation and things like that is completely lost. And with the rename that particular file, and you have no way of knowing that is what it was in a particular way. And if they copy it or do something, you completely lost that. So in a sense, we are completely missing some of these trustability which is needed when we are getting into this data intensive space. So we talk about data intensive, large big data. We are talking about all the things coming from sensors and being created and things like that. But we simply lack the trustability which is really needed. So can I take this data and say this is trustable? And we have seen that when people take a video and then change the video and it's gone, that you don't know what type of things they have done to that particular video or image or data sets. And if it is scientific data set, it is very easy to change because nobody is going to look into that particular data set to figure out what is happening and how it is happening. So in a sense, that is what is missing now in iRODS, and you can say about a lot of other file systems. And what is the way to deal with it? What is needed to get around that particular one? What is needed is something like the movie which came about in probably around 40 years back, called E.T. I suspect I'm showing my age in this particular one. Many of you are not even born during that time, for all I know. So E.T. Phone Home. So basically, can your data call back to the home base and try to say, hey, I'm fine, or who is using it and what is happening, and keep track of changes and auditing and so on and so forth. And that is what is missing, and that's what we are trying to see. Can we restore that? So if you're a person who is interested in legal or law, you can say that there is something called extraterritorial jurisdiction, or ETJ. It's basically when a government exercises an authority beyond its normal boundary. So basically what we want to do here is that normally the policies in IRADs are explicitly maintained and applied only within the boundaries of the IRAD zone. But can I even percolate or move it out of the IRAD zone and try to do it outside? And that's what we are looking at here. So power up, make a data object to be active. That's what it is. Data objects are now very passive. They have no control over what happens to them. They have no control about where they get stored. They have no control about which application can handle them. They have no control about which user can view them. It is all in the operating system. It is nothing to do with the data set per se. The data set is passive, is almost dead. It is just a bits and bytes and has no soul of its own. So what we would like to do is that can we, even inside IRADs, it's exactly the same. The data is stored inside the IRAD system is taking care of it. And it is the operating system which does it. Even the policies, the metadata, and all those things which we talk about even in IRADs is completely isolated from the data sets, the bits and bytes which are being stored, which are just stored as though they are just a buffers after buffers after buffers. That's what we've been talking about in a sense. And can we try to mitigate that? What we would like to do is give power to the data, free the data, and give them the policies and make them attachable to that particular one and set them free and then try to use them. So that is where the PEO comes in, or Policy Encapsulated Object comes in. What is it? It basically is this. It is basically a data not in isolation, but data surrounded by its own metadata, its own policies and services, and even an interpreter which is attached to that. So it is not just a passive bucket of bytes, but it also contains a lot of other things which go into it. It might have its own policies about ACLs, and it might have own policies about what are the metadata which need to be in there and how it is going to be coded, maybe in JSON format and things like that, and maybe a schema so that it says, okay, unless you pull this schema in there, I'm not a valid, viable data, and so on and so forth. So the PEO is something like that. And the idea is not new or novel. Object-oriented databases and object-oriented objects and Java and JSON and all those things are already there. And in particular, we know about how virtual machines and containers are basically being used so that you can take an executable and try to execute anywhere, everywhere, so that you don't need to worry about what are the underlying dependencies which are there. In a sense, containers basically did that for executables, and the PEOs are doing that for the data. So that you are actually carrying around a mini IRADs along with you in a sense, and then trying to use that in that particular setting wherever it is going to be located. So if you look at what is meant by a container from Docker, you can see that there are two important things. One is it can be moved reliably from one to another, and it includes everything that is needed for an application. So it is self-contained and it is portable. And that's what we want to do in the case of the PEOs. It's a live data object. You can trust and have an integrity on that particular one. It's a trusted environment in two ways. You can talk about the data being trusted, and the other way, the data can trust the environment where it is going to be applied. So that if the data is moved into an environment where it is not allowed to live, it can self-destruct if it really your policies have been maintained like that. It is self-contained and portable and independent, and like I said, chain of custody is part of it. It's a fair data principles and a full data lifecycle compliance in whatever be the location it is there, not just inside the IRAD system. And I should be really careful. There are places where even this type of things won't be helpful. For example, if somebody prints out a paper copy of the data, obviously it's going to be completely out of the control of even the PEO system. But that is something which we don't have any control over. What are the types of PEO one can have? There are a couple of types. One is called a tethered PEO, which is basically like the ET phone home type of thing. It's checkbacks to the home zone whenever it is there. So that whenever there is an update to a data, it can go and tell about the update back to it. And whenever there is a recall, actually the home zone can recall a particular data set saying that, hey, something is wrong. I'm not going to allow you to do that. Maybe the data scientist says that, oh, okay, we use the wrong type of calibration for that instrument. The data is not a really good one. Can I recall the data? Yes, now you can do the recall of the data. You can yank ACLs and change policies, not just ACL's policy, but a lot of other policies. And you can also have an integrated audit trail of things which are outside the IROD's environment as well as inside the IROD's zone system. And obviously, you can also do it is kill from far, so that you can delete a file which has been there on somebody else's laptop by doing something to it. That is a tethered PEO where the home zone always knows about the location and the copies of various cities outside. And you can see that this is different than the normal replication inside the multiple servers of an IROD system. Autonomous PEOs are basically simpler, and self-reliance is the main thing, but it can have a set of policies which can be applied whenever somebody wants to do it. It doesn't need to rely on the home zone for its livelihood. The architecture to implement something like this is really complicated. It is an active data architecture where you have policies which are event-driven and periodic-driven, which may need to be done. So in this case, the data is the king in a sense, or a queen, because it is going to go and say, hey, I need to do something now. It's not going to rely on application to do something to it, but the data is going to do something about it. So it is message-based architecture is needed, event-based architecture is needed, and rule engines are needed. All sorts of things which we have know about may need to be integrated together to do the architecture. Just to give you an idea about how something like this will work is what can be seen in this particular schematic. So you can follow the numbers 1, 2, 3, 4 type of thing. The data gets ingested, and then a PEO gets created. That means that all the things which are needed, like metadata, policies, interpretation, and all those things are there. And then when somebody copies that, maybe using an iGet, it goes into the remote computer and stays there in the storage system. But when in action number 4, when somebody opens or queries the data gets moved into a Sentinel, or basically an mini IROD's platform in a sense. And then some local policies gets applied, and then those policies might actually invoke home-based policies also. Might say, okay, you can need to go and touch bases with the home base to find out something about it. And it can go back and forth. 7 and 8 can be multiple communication cycles in there. And finally, everybody is happy about it and says you can open it. It can unpack the PEO, apply whatever be the remnant policies which are needed, and finally give the data back to the user. So you can see that you can actually control it. Even if somebody is taking the PEO and putting it into another remote computer, they won't be able to open it or use it and things like that. Obviously, I'm thinking that internally it is all encrypted and things like that. All those type of goodies are in there so that nobody can just look into it and get the data out of it just by doing an Emacs or VI on it or something like that. And what are the type of use cases? There are multiple use cases. Obviously, security and privacy are a couple of very important ones. Autonomy and automation are other 2 things. Compliance and fidelity, again, and tight beam data transfers from one location to another location type of thing, so that it doesn't get spoofed or picked up by somebody in the middle. And obviously, you can integrate it with Bitcoin technology and should be able to do, what happened here? And able to, excuse me. And able to do some nifty things with it. So there are multiple use cases where something like this can be applied. And I think I'm going to stop here.
Very good. We do have a couple questions. Thank you, Raja. I don't know if anyone has been able to see Regan. I think the attendees only see the active speaker.
Oh, okay.
If Regan, you would like to bless us with your beard for a second here. Raja, we do have a question around how is this different than digital rights management? Won't this just lock people down in terms of being able to use things if the object can control where they can be used?
Digital rights management is only one small part of it. You can actually implement a digital rights management using something like this, but you can do a lot more than DRMs in this particular case.
Okay. Regan, did you find the unmute button? Maybe.
He's unmuted now.
All right. Regan, can we hear you?
Hello.
Hello, Regan. How are you?
I tried saying hello, but I don't know if it's going through.
Yes, we can hear you now.
Okay.
Is there anything that you would like to add to what Raja has shared with us?
That this idea has been a long time in development.
Yeah, like I said, Regan has been one of the persons whom we talked about it, and then Regan left, and nobody was there to take it further. So.
Very good.
Thank you.
So we have a few more seconds. If anyone has a question, I think there is one hand. There's a couple hands up.
Okay.
We have a Dan Taylor, and then maybe a Nirav also has a question.
Sure. Go ahead. Can you read? Can you ask or read? Okay, I'm not able to see the.
Yeah. So Dan is now unmuted, and he can ask.
Yeah. Hi, Dan Taylor, Internet 2. How you doing?
Okay.
What do you see as the security concerns around around this active data object?
Yeah, actually, I'm really worried in a sense. This can actually open up a can of worms. That is one of the reason it has to be taken with a lot of care when you're trying to implement it, type of thing. It goes beyond the normal encryption. Think of that. It is basically talking back, and then, for example, if you take an object, and you are not just giving a key, a private key or a public key to somebody to go and open that and things like that. You're actually, the object can say, okay, only these type of people can go and look at it, and then can talk back to the home base and get the list of people who can go and look at that. So it is active. It is not like you're giving away a key to somebody and somebody can give it to somebody else and then they can open the data. So it is a lot more than that. So yes, this can actually create trouble, but can be used for really good purpose. So if you really want to have this particular one, an object to be viewed only by a few people, and how it can be done or can be run by a few people, you can do it in a very easy fashion, and you can control its life cycle from far. It's more of the policy which can be gets ported along with the data, which is important in here.
Dan, does that answer your question?
Yeah, thanks.
Very good. We have one last question. We're 1 minute over, but Nirav, do you have a question?
Yeah, I'll keep it brief. So that's really interesting, Raja, and good to see you, Regan. In terms of how you see this work, is it like a fuse mount that I would do on a system, and then that layer is doing a lot of the actual mediating, or how is this object going to become a citizen of my file system?
It is like how we are doing containers now. When you put a container, you say, okay, go and do some Docker to it. So similarly, this might be an object which let us say it is a Excel spreadsheet, so .excel, .xsl. But then when you make a PEO out of it, it's .xsl.peo. And it can be opened only by the Sentinel, and the Sentinel will take unwrap a little bit and then apply all the policies based on that. So it is almost like a layer, like what is happening with respect to the Docker. You will have a layer sitting somewhere which is going to do that.
Okay, thank you.
Okay.
And presumably that would also be authenticated and have access to control.
Yeah, you actually in a real paranoid case, that whole thing goes along with the PEO.
Right.
Yeah.
One last comment about any private entity would not necessarily be happy to lose control over data they received, because it would still be under control of someone else. So that's an interesting thought experiment as well.
Yeah, you can actually, it is like for example, what is happening now? Remember, good old Apple is able to track every iPhone it sold, right? Or unsold or not sold. It doesn't matter. They can track it. If they can track it, why can't we track every data, which is really important? It's not for all the data. It's not for my email data. I don't want to take my email and wrap it out into, encapsulate it into a policy encoded object. No. I want only for really important ones. Let us say the Bill of Rights or something like that.
All right. Well, thank you, sir. Regan, it's great to see you.
Thank you.
Raja.
Thank you. I'm going to unshare.
And we have some more questions in Slack. So Raja, if you're happy to follow up, I think there's some interesting conversations to happen offline.
Sure, I will do that. Thank you.
Very good. Thank you. Thank you.